Okay, so welcome everybody to the gRPC Community Meetup, and thank you for being here. My name is Maria Cruz. I'm a program manager in the open source program office. And as we continue to welcome people into this meeting, I am going to give the floor to Srini, who is going to present a demo. Srini, the floor is yours.
All right. I hope you all can see my slide.
Yes, we can see them.
All right, great. Yeah, it's exciting to see a great attendance. Thank you all for joining this community meet. My name is Srini Polavarapu, and I'm with the gRPC team at Google. So in this presentation, I'll be talking about the service mesh functionality in gRPC. And how it makes gRPC an indispensable tool to build scalable applications. And please feel free to interrupt me anytime and ask questions. So let's get started. So as we know, modern applications are built using service-oriented architecture, where your business logic, basically the backend business logic, is implemented as a collection of smaller services talking to each other instead of a large monolithic service. So for example, an e-commerce site would be made up of a front-end service, which would typically receive requests from your customers. And then in turn, it will talk to various other services like shopping cart, billing, or shipping, inventory, etc. To fulfill the customer request and render their web page, right? So the more complex the business logic, the more compelling it becomes to use service-oriented architecture so that different teams can independently develop the services without blocking each other. But of course, it comes with additional complexity, like how can a service evolve its APIs and interfaces without breaking other services that depend on it? And also what happens if different teams want to use different languages? And typically, in a service-oriented architecture-oriented application, the east-west traffic, which is the traffic between the microservices, is typically several orders of magnitude more than the north-south traffic, which is the traffic coming from users to your front end. Right? So that's why it becomes even more important to optimize and have your east-west traffic as performant as possible to save cost on compute and network. And you may also want to limit the amount of time one service waits on the other service to return a call so that the overall user experience is not compromised. So all the problems here that I mentioned are solved easily with gRPC and protocol buffers. And that's why gRPC basically is really a great tool for building modern applications. Right, so continuing from the previous slide, there are other challenges too when you want to build microservices-based applications, like how do the services discover each other? And how requests are load balanced to many replicas of a service. Typically, a service is made up of many backends, or sometimes we call them endpoints, which are actually listening on the service port and providing you the service, right? And then you also might want to secure the traffic between the services. You want to maybe encrypt the traffic, and you may also want some easy ways to figure out if something goes wrong, like you want metrics, you want to be able to trace your calls from one end to the other, right? So, so even if you're using gRPC, right, you will face all these problems, and that's why you would need a service mesh solution. For example, Istio is a very well-known, popular open source service mesh solution. And gRPC itself does not have any of this functionality until now. So in the remaining slides, we'll talk about what is this about and how we are bringing this functionality into gRPC. Right. So before that, let's understand how a gRPC application is deployed in a service mesh. So in a typical service mesh, a sidecar proxy is deployed with each instance of the service. This sidecar proxy is basically running in the same pod if you're using containerized services, or in the same VM along with your application. Right. So the sidecar proxies, these are the ones that get the service mesh policies from a control plane. And these policies can tell the sidecar proxy on how to route a particular request, how to load balance, or how to encrypt a particular request, and so on. Right. So like any other application, a gRPC application would simply do a DNS lookup for a service that it is trying to connect to, and open one connection to the virtual IP of the service, right? This is same as any other application, right? And then this connection is then intercepted by a local sidecar proxy, and which then applies the mesh policies and routes to an endpoint in the destination service, right? So the request is also intercepted by another proxy on the server side in order to apply the server side policies. For example, mutual TLS, right? So if you want to encrypt and enforce the mutual TLS policy, then you need a proxy on the server side also. So the application is essentially unaware that they are operating in a service mesh. The service mesh functionality is seamlessly provided by the control plane and the sidecar proxies acting together, right? But there are some drawbacks in this solution, and this is the most common solution that you would find in service meshes today, right? So what are these drawbacks, right? Right. So first, obviously, there is a performance and cost overhead for running these extra proxies in your service mesh. Our internal benchmarking shows that you can get 3 to 4x more requests per CPU second if you don't have these proxies in the middle. And this is the networking cost that I'm talking about. And also there is a benchmark by the Istio project that shows that the latency of each call can go up from 0.6 milliseconds to 2.6 milliseconds. That is the 90th percentile latency. So that's a significant latency added to each and every call in your mesh. And also proxies require some tuning because you can run into a situation where a fast application is bottlenecked by a slow proxy, right? Then there is also additional complexity in the path a particular packet takes because it needs to be intercepted by the proxy on both ends of the connection. There are a complex set of IP table rules that are created by the service mesh, which allows these proxies to intercept the traffic. And as a result, it gets harder to debug if something were to go wrong. And then also proxies are additional binaries in your service mesh, which means there is an overhead of lifecycle management like any other binary. You have to worry about deploying, upgrading, health checking these binaries, making sure that they are running, and then dealing with any security issues and all that stuff, right? So all these things also make it a little bit harder to manage these proxies on your own in VMs when compared to pods, right? Yeah, and then there is another aspect where if you want security, then typically proxies are the ones that encrypt and de-encrypt your traffic, but your application is actually sending plain text request, right? So that may be acceptable in most cases, but there may be some cases where that is not acceptable. You want a true end-to-end encrypted solution, right? So that's why we we thought that by adding service mesh functionality directly to gRPC, those who are investing in gRPC and using gRPC in their applications can avoid all these limitations. And then it becomes a compelling reason to adopt gRPC for building scalable applications. Yeah, I'll keep checking if there are any questions in between. All right. So this is how it'll look like if we go proxyless. The gRPC library, which is linked to your application, can directly talk to the service mesh control plane and route request, all the requests to the destination service, just like a sidecar proxy would do. And this would make it easier to migrate your gRPC applications to a service mesh and get the most out of your investment in gRPC. So this kind of proxyless model is already being used at companies that are building, global scale services. All right. So to make this happen, we decided to add support for Xds APIs in gRPC. So what are Xds APIs? These are the same APIs that Envoy proxy uses to talk to this mesh control plane. Now, Envoy is the de facto proxy used in many service mesh solutions, and Xds APIs were developed as part of Envoy development. Right? So Xds APIs are open and extensible and has a very strong community support. And because we also want to support coexistence of proxied and proxyless workloads in the same service mesh, it made total sense to use the most popular APIs out there. So that's why we picked Xds APIs a couple of years ago, and we started developing and started adding support for Xds in gRPC. All right, so I will do a quick overview of what Xds APIs are. There is a lot more to Xds APIs than what is shown in this diagram here, but I will keep it simple here, just to understand the concepts. So the Xds APIs are a collection of APIs to discover various resources in a mesh, and I'll talk about what these resources are. And hence the name Xds, where X stands for the type of resource, like a listener, a route, a cluster, or an endpoint, right? So you would have LDS, EDS, RDS, and all sorts of DSs, basically. So in a service mesh, obviously, there are services, and these are typically known as virtual services because it is usually backed by a virtual IP and a port to which other services connect to. But this virtual IP is basically backed by a set of backends or endpoints, which actually deliver you the service on a different IP and a port. So when you look up a virtual service, you typically do a DNS lookup, and then that DNS lookup will resolve in a virtual IP, and then the request is sent to the virtual IP, which is then intercepted by the sidecar proxy. But now the proxy needs to know everything about such virtual IPs, right? Because you don't know which application the proxy is fronting, right? So it can receive a request for any of these virtual IPs for hundreds of services running in the mesh, right? So that's why then the proxy would do something called a listener discovery request in order to get the information about all the virtual IPs in the system. So in case of gRPC, the application already knows which service it wants to connect to. So we created a new type of listener called API listener as an optimization, which is looked up directly by the name of the service. So there is no DNS lookup performed. Right. The next step is to figure out how to route the traffic to that service and what policies to apply. And this information is obtained using the route discovery service. So this configuration may include various rules like match on a particular header value and route to a particular cluster, or split the traffic to multiple clusters based on some configured weight. So you can do lots of fancy stuff with your routing. And a great use case is, for example, a canary deployment, where you want to do A/B testing or you want to roll out a new version slowly. You can configure the weights accordingly. So once you have the cluster to route the request to, the next step is to do the cluster discovery. And with CDS, you get the cluster configuration, which can include things like what is the load balancing policy for this cluster? Is it round robin, or is it least used, or what is it, right? And there can also be security policies associated with this cluster, like it only accepts MTLS requests, for example, right? So a cluster is made up of endpoints, which are the actual service instances. And these endpoints could be spread across different zones and regions, if you're talking about a cloud platform. And these are known as localities. So locality, you can think of it as a deployment in a zone, right? And that information is obtained via endpoint discovery service. So you can see that how the mesh resources are very well aligned with Xds APIs. All right. Okay. So how do you start using XDS in your gRPC applications and go proxyless, right? And it is quite easy. The way we designed is that all you have to do is, instead of using the default DNS scheme when you create a channel to connect to a service, you have to use this new scheme called XDS. So in this example, you can see when a channel is being built, instead of saying DNS colon, you're just saying XDS colon and the name of the service you're using to that you want to connect to. It's that simple. You also have to provide a bootstrap configuration, which basically tells your application where your XDS server is. Where is your control plane, basically. And this bootstrap configuration can include some additional information like what are the credentials to connect to the control plane, what is the ID of this client for debugging purposes or for some accounting. And then it can also provide some platform specific information like which zone the client is running in, or what is the project ID and so on, right? So it's that simple. All you have to do is change your scheme to XDS and provide the bootstrap file. And then another advantage here is that you can pick the scheme on a per channel basis, which means you can connect to some services via a proxy if you use DNS, and you can connect to some other services without a proxy if you use XDS, right? So this makes it very easy to migrate to proxyless service mesh slowly. So for example, if you want a feature that is not available in proxyless gRPC today, you could continue to use a sidecar proxy to access those services that require those features. Right? So there will be few other additional small things that you will have to do when new features like security rolls out. For example, you will have to provide XDS credentials to your channel, or you will have to start an XDS server on the server side instead of starting a regular server, right? So that's why it's important to plan ahead when you're writing your gRPC applications. It is good to consider making these things dynamically configurable for your application, so you don't have to rebuild your applications when you decide to migrate to a service mesh. Right, if no questions, I'll keep moving forward. So obviously, we talked about the advantages of a proxyless service mesh, but what are the limitations, right? So there are some downsides too. And the obvious one is that mature proxies like Envoy are very feature rich, and they have a good ecosystem of third-party filters and tools, especially in the area of observability. But gRPC is also catching up quickly. We are rolling out more and more features. And also note that gRPC has interceptors to provide extensibility. And there is also a good open census integration with gRPC through which you can get metrics and tracing. And just as a side note, open census is being replaced by open telemetry, which will also have gRPC support. The other downside is to get XDS functionality, you will have to upgrade to the version of gRPC that has the functionality that you need. And it is usually not an issue because developers building microservices-based applications typically have a very good CI/CD infrastructure. And also, you can continue to use proxies, like I explained earlier, if you think that a legacy application cannot be upgraded and you cannot move to proxyless. And currently, we have limited language support, but this is good enough to start off with most major languages. I have a question here. Let me take a quick look. So the question is the idea that XDS servers will eventually be implemented by other service meshes or standalone servers? Otherwise, our applications become tied to Envoy. Is that correct? So the idea here is that XDS APIs are becoming the de facto APIs for implementing service meshes. Basically, if you look at a lot of popular service mesh solutions like Istio and other cloud vendors, you will see that almost everyone has adopted XDS APIs to talk between their control plane and Envoy, which is the sidecar proxy, right? So by using XDS APIs in gRPC, you don't get locked into any vendor, basically. So you can take your gRPC application to any platform that supports XDS APIs. Right. The next question is there any tooling you would recommend for bootstrapping an XDS server to advertise your endpoints? So the Bootstrap server, the Bootstrap configuration actually contains some platform-specific information. So you would expect the platform provider to provide you the tools to generate Bootstrap configuration. I think that's what the question is, right? So normally you can write your own Bootstrap generator if you know what is required for a given platform. And right now it's quite straightforward. You just need to provide the address of the XDS server, the credentials, and some other small information. All right, let's continue. Yeah. So okay, I talked about the downsides, right? Yeah. So what is the current status right now? So we made great progress in 2020. That was the first time in June of 2020 we introduced the XDS infrastructure in gRPC. So prior to that, the team has been working on it for about a year to bring the XDS infrastructure into the gRPC stack in multiple languages. And after that, we released a number of traffic management features, as you can see in this list here. There are more features in the pipeline which are scheduled to be released quite soon. In this quarter and coming quarters, you can expect some GA versions. So the link that I provided here basically is constantly updated. And that's where you can get the latest up-to-date list of supported features. So let's talk about what control planes support this today. So if you are looking for control planes that support proxyless gRPC applications, take a look at Google Cloud's Traffic Director that has production-grade support. So Traffic Director provides global load balancing such that your requests from a client are routed to the closest available backends of a service. Obviously, it accounts for the health and the capacity of the backends, and it also sends any overflow traffic to other regions. And also, if a region fails, then it can completely fail over to a different region if you have made your services global. Right? Another advantage with Traffic Director is that it uses centralized health checks to monitor the health of all the backends of all the services in the mesh. This avoids, an n-square problem that you can run into where each client is trying to health check each of the backends that it connects to, right? So that kind of health check can put a lot of load on your backends. And the good thing in Traffic Director is that it also supports gRPC health check protocol. So that way you can directly use gRPC health checking in your applications. And then Traffic Director can also discover the endpoints in a given service as they come and go. So it's often the case that sometimes you are upgrading your deployment to a newer version, so it slowly phases out old pods and brings in new pods, right? So the list of endpoints keeps changing, and Traffic Director keeps track of that and provides the latest, greatest to the clients. And also your services can be scaled up and down based on the load and various configurations that you have set. And it works on GKE as well as GCE. So you can even use VM-based legacy applications in the service-less, in the proxy-less mesh. Istio is another popular service mesh product, which is open source, and there is some experimental support in Istio, but full support is not yet there. We also see another thing called Go control plane, which is a lightweight XDS server that some are using to start building their own advanced servers. So right now we see an open issue in the project, but not much work has been done to support proxyless gRPC. All right, I'll take a few questions here. So Envoy users usually complain about the configuration overheads. Does Xds gRPC makes user configuration easier, and how? So configuration is basically done based on the control plane that you're using. So if you're using Traffic Director, then obviously you will go figure out how Traffic Director is configured. If you're using Istio, then you have to go figure out how Istio is configured. The control plane is responsible for taking your configuration and then converting that into XDS APIs, and then push it down to the data plane components like Envoys and proxyless gRPC application, right? So I would think XDS APIs itself are complex to understand in the beginning, but most users don't have to worry about that. All they care about is how do you configure your services at the platform level. The next question, if you have a deployment where a gRPC server needs to talk to another service over REST, this is an internal call out. Does this mean that over XDS APIs, this gRPC service will have capability to talk to non-gRPC services as well? So a gRPC client can only talk to a gRPC service. If you want to talk to HTTP services, obviously you will need a gateway in the middle, which is the gRPC HTTP gateway that converts your REST calls to gRPC and vice versa, right? So you can obviously use an HTTP service in the mesh if you have a gateway like that. So all the requests will have to pass through gateway. And that HTTP service can also be part of the service mesh if it is deployed via a sidecar proxy. Right, so Envoy will support HTTP services as well as gRPC services. So it has full support for proxying gRPC also. So you can just deploy without using proxyless gRPC, but only using Envoys and mix and match your HTTP and gRPC services. Another question is, for local development, what choices are available for XDS server? I think you should take a look at the Go control plane, but as I said, there is no support available for proxyless gRPC. If you're inclined, you can take up that issue and contribute to that. Okay, yeah. Mark says that's exactly what Mark was looking for. That's great. All right. Animesh is asking the question again, saying it is more of to do if you still need a proxy sidecar. Yes, I mean any service in the mesh would need a proxy sidecar a sidecar proxy to provide the mesh functionality, right? Because the application remains unchanged. Right? All right.
Just to add a comment to that last response, ultimately your proxy sidecar might be providing other functionalities such as protocol translation. So in this case, if you're looking at translating from HTTP to gRPC, that is that's an independent piece of functionality. So even if the sidecar is not needed anymore for the XDS functionality, you might still want it for that protocol translation piece.
So I'm not sure if you can hear me, but it's not about protocol translation in this case. Think of it more like this gRPC service is handling its client. That is fine. But in order to do that, let's say it needs to make a call out to some other REST service for its own functioning. Does that mean that given that it's part of that XDS service mesh, does it have routing information to talk to that service? Or like, am I able to completely eliminate the sidecar in the gRPC server, or I still need the sidecar to talk out to another HTTP service, REST-based HTTP service in the service mesh? That service itself would need its own sidecar. That is not what I'm questioning. I'm asking more for this gRPC server. If it needs to go talk to some other REST server, it's not doing any protocol translation. It's a completely different request, maybe getting some context or some other information. Would it still require another sidecar just to go talk out to that HTTP service?
Yeah, thanks for clarification. So the answer is no, it would not require any sidecar. You are actually connecting to another service, which let's say you can do a DNS lookup for that service and directly make a call to that service, right? So gRPC, if you mix in HTTP, let's say client, you can call out to HTTP services independent of what the gRPC part of your application is doing.
Okay, got it.
And also,
the important thing though is in that case, you're using some other HTTP library to do those requests, and that would not use the service mesh for doing that call. So it's if you're wanting gRPC stuff to participate in the service mesh, it would. But if you're just using something off to the side that's sort of separate, then it would not participate unless you started doing what you would do in other cases, like having a sidecar or something like that to sort of force it to.
Yeah. Okay. Another important thing worth mentioning again is that even within gRPC, let's say you are calling out to two different services of gRPC, right? One can still be called through XDS, and the other one can be called through DNS, because this is all per channel scheme, right? So, so let's say you have a legacy application sitting outside of the service mesh. You could simply use the current mechanism of opening a channel and using the default DNS resolver and connect to that legacy service. And then for other services in the mesh, you can use the XDS resolver. All right, I have one more question here. Is Traffic Director the only gRPC server? Yes. So as far as I know, Traffic Director is the only production-ready product out there that supports gRPC proxyless workloads. So I'm thinking
I think it's asking, is Traffic Director is it only for only gRPC services? So you can use Traffic Director with Envoy directly as well, if that's what the question is.
Oh, okay, yeah. So Traffic Director is an XDS compatible control plane. So you can deploy your service mesh using Envoy also, and it also adds gRPC proxyless support. All right. So this is my last slide here. So if you like to understand the architecture or contribute, the gRFCs are the best place to get started. They have a lot of information about the architecture and how it's been implemented in gRPC. There are a lot of other gRFCs in flight for the upcoming feature, so take a look at those too. And keep an eye on the XDS features link here. We keep updating them as and when we add more features. And there are a few other useful links here. And with that, I conclude my presentation. Any more questions? Feel free to even ask the questions. You don't have to always type it too. I think we can all hear everyone here. All right, Maria, you can take over.
Awesome. Thank you so much, Srini. And I was going to ask you if you are planning on publishing the slides.
Oh, yeah, sure. Yeah, I can do that if you let me know where to publish. I can either send it to you or let me know.
Okay, cool. Thank you. And I just want, before I do the breakout rooms, where we are going to connect in smaller groups, I wanted to give everybody this information. If you heard about this meetup on Twitter and would like to receive an email, this is the Google group that we have set up for gRPC. So feel free to join that, and then you will find out about future meetups as well. And if you would like to present a demo showing how you use gRPC, we would love to see that as well. And this is the email where you can email us about this. So don't be shy. We welcome most demos. So please speak up about this as well. And now I think, Jamie, if you're in the call, can you break us into rooms of 4 and 5 people, more or less, please?
Can I ask a quick question?
Yes, please do.
Sure. We have the clients as the data flow, Google data flow as the gRPC clients, and gRPC is running on Kubernetes GKE. Can I take advantage of Traffic Director to connect data flow clients to gRPC services?
So the data flow clients are also talking to the data flow service while talking to other services in the service mesh?
Yeah, data flow clients are receiving the data from some GCS bucket, and then they are calling the gRPC services to ingest data into our backend database as a kind of ETL job. So the challenge we had in the past was putting a kind of single gateway and having ingress to route all the things, a single point of failure. And also we had old issues like when you increase the parts, it is not, NY was not able to detect, not NY, but the default L4 gateway was not able to detect the new servers. So.
Right, yeah. So this is a great use case where sometimes middle proxies, gateways can become a bottleneck. Because if you have large number of services or large QPS flowing through it, the scaling can become an issue, right? So if you use proxyless service mesh or service mesh in general, then the clients can directly talk to the services without needing to go through a middle proxy, right? So, and obviously then in that case, you need a service mesh control plane, and Traffic Director works perfectly well for GKE.
Sounds good. Thank you.
I'll just note that in some of those environments, I think data flow, it calls you, you don't call it sort of idea, like it spawns your binary and things like that. You may have to set up the environment outside of data flow so that everything's available whenever your process ends up running. But if you had already set up Envoy and had tried out that, you would have gone through that process already. But while almost everything is in the library itself, there's some bootstrap information that gRPC will need, and that is generally sort of injected to the environment. And in some of those cases where your component is sort of built into a framework and is sort of executed off to the side as a sort of a separate process and stuff, you might need to figure out a little bit in those environments how to implement.
Thank you. And curious about Java client also can do this Xds schema. Will it support? The Xds endpoint kind of schema that Java client also supports is only Go right now.
No, it's Java is also supported. Yep.
Okay.
So right now we have Java, C++, Go, Python, PHP, Ruby, and C#. But moving forward, we are not planning to add support in C# because there is a separate pure C# stack called the .NET stack that is being developed. So in future, if needed, we will add Xds support in that stack.
So I don't think I have the capacity to do the breakout rooms at the moment. Oh, there are more questions. So if you have more questions or comments, just feel free to speak up or write them in the chat.
Yeah, and we can also ask questions on any other topic related to gRPC. We have a lot of gRPC contributors here on this call. So if you have any other questions, feel free to ask. So is Russ supported? Okay, so I don't know the plan for REST. I'm not sure if any Rust contributor is here on this call. Maybe they can chime in, but as far as I know, it's not planned. And I also believe there is at least one Rust implementation that uses the gRPC C core. So if that's the case, then most of the Xds functionality so far has been implemented in the C core. So the wrapped languages like Python, for example, those languages get this functionality for free. It won't be the case for upcoming features. There will be some small amount of work that will be required in order to expose the Xds functionality in the wrapped language. For example, if you want to create an Xds server, you have to provide that option in the wrapped language layer to specify that you want an Xds server or you want a normal server. Similarly, if you want to do your MTLS via Xds, then you have to tell your channel at a wrapped language layer that you are planning to use Xds credentials versus your provided TLS credentials, right? So this will be very small things. So if Rust is wrapping C core, then it shouldn't be very difficult to get Xds functionality in the Rust implementation. All right, looks like no other questions.
One more question.
Oh, sure. Yeah.
So this is regarding the transport thing that we brought up, just MTLS thing. I was exploring the application level transport security that Google is supporting, basically workload identity or something like that to provide some kind of mutual identity for the microservices plus transport. Is there a tight support for gRPC stack side to support that as a transport?
Does anyone want to take this? Security experts.
So because you mentioned ALTS specifically, Google has published a white paper on ALTS, and it is being used in certain scenarios for internal communication or for connectivity from the Google's public cloud to Google's private cloud. But in the service mesh world, the emphasis going forward is to use TLS instead of ALTS. And there is definitely some amount of MTLS support that's been available in gRPC for a while. And I'll let folks on the bridge comment further on what's available.
Yeah, so for service mesh, when you want to do MTLS between your own services, we are working on providing the MTLS support in the service mesh via the Xds APIs. So you can see some gRFCs in flight that is trying to add this functionality. And the solution will basically automate getting a identity-based certificate from a certificate provider or a CA basically, and we will support one type of interface that will be easy to implement, on a file-based certificate rotation. So you don't have to worry about refreshing your certificates, and it'll basically rotate certificates in some periodic way, and then provide the MTLS, including the identity of the workload.
Yeah, that would be awesome. Like, main challenge for me is certificates, shipping them and mounting them for every services.
Yeah. So, I mean, if you look at what Envoy provides today, it's all provided as part of, let's say, if you look at Istio, for example, you can see that this is part of the solution, MTLS.
One more question about the gRPC stack. There is a GoGo Protobuf thing, and in the beginning I had a little confusion like which one I should use. I'm curious about what the community is using GoGo FastBuf default gRPC.
Yeah, I will let our Go contributors take this question.
Yeah, so both should work, whether you use the Golang proto implementation or the GoGo proto implementation. I will say it seems like a lot of our users do use GoGo proto, but we on the team don't use it at all. And I'm only sort of personally a little bit familiar with it. Like I've used it, but I'm not that familiar with it. So my recommendation would be to use the Golang protobufs.
Sounds good. Thank you. So if anybody using that Buff, there is a project called Buff Builder or something like that for managing the protobufs, linting the protobufs. Just because it's open discussion, I thought like anybody has opinions, those kind of tools.
Right. Yeah, if anyone wants to take this.
Yep, we have been using that Buff project, and it's working out pretty well for linting and compiling the Buff protofiles into several languages. We're basically using for Java, C++, and Golang. If you have any specific question about that. I could try and answer.
Yeah, in general, I was using the Proto tool in the past. That is from, I think, Uber or somebody.
That was from Uber, and that has been deprecated, and they have also switched to Buff tool.
Oh, okay. And what do you guys use for formatting the protos? If I was trying to explore something with VS Code plugins, but curious.
No such formatter plugins. We don't have. Whatever the IDE is providing is pretty much standard that we use.
Thank you.
Since we are on that topic, they're working on something really interesting called Protobuf Schema registries. So we could use Protobufs as dependencies, something like we have a Docker registry, and we could use those Docker registry images in other Docker images, the same way we could construct our Protobufs. So that would kind of solve a lot of our problems with the import parts of Protobufs. But I have no idea till where they have been, or is there any other project that's working on the similar problem?
Yeah, that is a good idea. I also saw something from Confluent team. They're also building a registry to support schemas and protobufs, I guess. One other thing is I'm facing issues is like we have some people using Avro as in the data flow and ETL side, and microservices we are using Protobuf as the serialization. I wish there is a kind of any tools to code gen or translate serializing between the Avro to Protobuf and back and forth. I think it's an off topic, but just because most of the storage, when they store the data in the files, and they store it in the Avro files, and if there is an easy way to translate. Only library I find is from LinkedIn's, there is an Avro parser for Go language, but yeah, it is not like we have to write code for it, and it's more of generic record processing kind of thing.
I think some projects will pass generic payloads. So you can imagine some like databases or something where it's a little bit more generic data that just sort of gets plumbed around. And you might have Proto or JSON or Avro or something like that. And I think that they just sort of keep it as bytes in the Proto. In your case, it sounds a little bit more like the data is coming in as Proto, but then you're wanting to continue, sorry, as Avro, and then you're wanting to continue processing it. And it sort of gets split up and recombined and everything through the rest of your microservices. Is that right?
Yeah, so we get messages in PubSub and then take them and call our gRPC services. So there should be an easy translation thing.
Yeah, I'm not aware of anything that would, let's say, take an Avro schema and spit out a Proto schema and then also do some code gen to convert between the two or something like that. I've not seen something like that.
Is Protobuf supported in BigQuery side as a schema, or it's a limited? I know Avro they support and comma support JSON, I guess.
Okay, it sounds like we are approaching the end of this meetup. Thank you all for joining and participating so actively. And again, if you have examples of how you use gRPC, we would love to see them. I'm sharing that information once again. There's a Google group and an email, so please do email us about this so we can feature you in the next community meetup. I'm going to go ahead and stop the recording. And thank you, everybody, for coming, and we'll see you again in the next one.
Do you have the slides, Madam?